Hi, this is Mrs. Ziegler, and I'm going to go through your unit atomic structure notes. So you are going to use this presentation in order to complete those the 6 pages that you're cutting out and putting into a booklet to use as your notes. So the first question that you need to ask yourself for this unit, or one of the driving questions, is what properties differentiate atoms from each other? Okay, so these are the essential questions that we will be asking ourselves that you are responsible for in for this unit. Okay, so are all atoms of the same element alike? How do atoms become charged? What does the decimal number on the periodic table represent? And what information is conveyed by an element's position on the periodic table? Okay, so some of this information we're going to touch on. We're actually going to go into most of the information, specifically the periodic table, in our next unit. Okay, so for this particular unit, we're really concerned with the first question. Okay, actually the first and the third. All right, so looking at your booklet, we're starting here with the introduction of the periodic table. Again, you need to know your periodic table in order to find the information that you need. Okay, so here in your periodic table, you can see that these are columns. Okay, so the columns, all right, it says here are the groups, whereas the rows, which are, there's a total of 7, 1, 2, 3, 4, 5, 6, 7, are periods. Okay, using a periodic table, you will see this information on most periodic tables. You've got the atomic number, element symbol, element name, and then here on the bottom with the decimal is the average atomic mass. So the periodic table is organized so that elements on the left, so the left of the staircase, which here is what's considered the staircase, the solid black line on the periodic table. Everything to the left of the staircase are metals. Everything to the right of the staircase are nonmetals, which actually we'll find out a little bit more, but hydrogen, which is over here, is actually also a nonmetal. But you don't have to worry so much about that until we get to the periodic table. This is just an introduction. So the way that they're arranged is that every group, meaning every column, all the elements in those columns have similar chemical and physical properties. Okay, so here on the next page for the parts of the atom. All right, so important terminology. So we know already, or at least we should know, what the atomic number by definition is. It's the number of protons of an element. For neutral elements, meaning elements or atoms that have no charge, it's because the number of protons and electrons are equal to each other. That's where we get ape. Mass number, which by definition is the number of protons and neutrons combined, meaning the sum total of protons and neutrons, is the mass number. Okay, both the atomic and the mass number are always whole numbers. You should never give us a decimal. Okay, so we get the number of neutrons, where again, that's where the man comes in. It's mass number minus atomic number, which is the number of protons, give us the number of neutrons. Okay, another vocab word, isotopes. So isotopes are atoms with the same number of protons, but different number of neutrons. Okay, they are chemically alike, but have different mass numbers. That's what isotopes are. An isotope name is written where it is always the element's name or the symbol, and then the mass number. Okay, so here is a picture of 2 different isotopes of beryllium. Okay, so what you're going to do is we're going to write the isotope symbol, or I'm going to give you the isotope symbol and then the isotope name. And essentially what you should do is you should color yours. Okay, so if we have beryllium, okay, I have 2 different isotopes of beryllium where it's 9 and 4 and 10 and 4. So remember that top number, 10 and 9, that's the mass number. Whereas the 4, it's the same for both because that's the atomic number, which means also it's the number of protons. The chemical symbol is the, symbol of the element, which is beryllium. To get the name, it's just the element's name and then the mass number. All right, so if we were to color code and color code our nucleus for both isotopes. If I say red for protons and yellow for neutrons, to make my protons for both of the atom, they will be exactly the same, 4 protons. To get the number of neutrons, which are the yellow ones, it is whatever 9 minus 4 is, or 10 minus 4 is, that's the number of neutrons. Again, same exact atom, but they are isotopes of each other. All right, now on to types of ions, which again, you are responsible to know for this particular unit, but it will not be on the quiz. It will be on your test. So, what is an ion? An ion is an atom or group of atoms with a positive or negative charge, meaning it is not equal to 0, meaning that an ion forms when an atom loses or gains electrons. Ions can either be positive or negative, where a cation is an atom or group of atoms with a positive charge, meaning they have more protons than neutrons. Or I'm sorry, not neutrons, electrons. Okay? To become a cation, to name the cation, we use the element's name. So whatever the element's name is, that's the name of the cation or the name of the ion. So an example of this would be, I have Na1+1. So Na is sodium, and it's a sodium ion, or in this case, we say sodium cation to show that it's positive. Okay. Another example, Ca+2, which is a calcium cation. Okay, so these are positives because ions are cations are positive ions. An anion is an atom or group of atoms with a negative charge, meaning they have more electrons than protons. To name an anion, which again you will be responsible to know, you are going to change the element's name to include the suffix IDE. So an example, O-2, that is oxygen is an atom. What we do is we take oxygen, we chop off at the vowel. In this case, we chop off at the Y, and we add the suffix of IDE. And this is an anion because, again, it's negative. We could say oxide ion, which oxide, the IDE tells me it's an anion already. Another example would also be Cl-1, where it'd be chloride anion. Again, we're going to chop off at the vowel, in this case the I, and then we add the IDE. If for some reason you happen to not do it correctly when we're doing the naming, I will not take points off as long as you recognize you're chopping off at a vowel and adding the IDE. But as I said, we'll do enough practice of that. All right, so we're going into isotopic notations. So whenever we do isotopic notations, like the picture of beryllium's isotope, we always have the mass number, the atomic number, and then if it's not neutral, meaning that if it has a charge, meaning it's an ion, then you put the ion. Okay, so a model of nitrogen atom that gained 3 electrons. So we're doing the isotope symbol and also showing how the atom looks like when it loses or gains electrons. Okay, so here, when I'm doing, so I'm telling you that it's a nitrogen atom and it's gained 3 electrons. So its symbol will look like this, 14, okay, 7 atomic number. So we know that the mass number is 14, the atomic number is 7, the symbol for nitrogen is N, and it gained 3 electrons, so it's a -3. The name for this is, again, it's a negative ion, so I have to change the element's name of nitrogen into nitride, and since it's an ion, it's nitride ion or nitride anion. You do not always have to have where it says anion or cation, as long as you have the name correct. Then we're going to color code. So I know that the protons are red, the neutrons are yellow, the electrons will be blue. So we know that our atomic number, which is the number of protons, is 7. The number of neutrons, which 14 minus 7 would be also 7. And then on the outside, so we know that nitrogen, for its atomic number, is 7. So as an atom, I would have 7 electrons. But because I added 3, I will have 10. So we were showing here where in the electron cloud, I have a total of 10 electrons because this is an ion. All right, we're moving on to atomic mass, which again, this is the math portion of this unit where you are responsible to know this information, which is why you're going to have it in your notes. So what is the atomic mass unit? So AMU. So this special unit, which later on we will interchange AMU to also grams, but right now you just have to recognize the definition of the atomic mass unit, which it is the special unit that's based on the carbon-12 isotope. Okay, it's defined as 1/12 of the mass of a single carbon-12 atom. Okay, so essentially, you don't actually have to know this information in terms of one AMU, one atomic mass unit is equal to these many grams. You just have to recognize that the definition of what the atomic mass unit is. Okay, the unit is also used to report the mass of a single particle, which this is what that is representing. Okay, when we're calculating atomic mass, it's like calculating your grade in a class. Okay, so we're going to pretend that you have, this is the percentages, or this is the way that your grade is weighted. It's 75% on tests, 20% on quizzes, 5% on homework. So like in your class for chemistry, it is actually 55% is your assessments. It's both tests and quizzes, whereas your work in class is 25, and then, 15, and then your final is worth 15. That would add up to 100. Okay, so these are the grades that you actually earned for this fictional class. Okay, so we have to figure out what is your grade going to be when we calculate it. Okay, so what you're going to do is you're going to take 75 divided by 100, which essentially is the percent. This is actually how you change 75% into a decimal. Okay, it's 75 divided by 100 times 80, which that is the grade for your tests. Okay, and then you're going to add that to 20%, which again is 20 divided by 100 times the percent of the actual grade of what you got, which is 85, plus, and then again, homework is 5%, which is 5 divided by 100 times the grade that you got. So once you calculate this, that's going to add up to what your actual grade is in the class, which would be 82%. Okay, that is how you would calculate. Another way that you can do this, you don't necessarily have to do 70 or whatever the number is divided by 100. You can just take wherever the decimal is and move it 2 places. So the decimal would be here, and then you just move it 1, 2, and that would make it the same thing as 75 divided by 100. Okay. All right. So that's how you calculate your grade. Same way that you would do average atomic mass, which is the weighted average calculation, meaning it is the mass or the mass of the particular isotope times the percent abundance, meaning how much of that particular isotope is in the world. So this is the type of calculation you'll see. So you're going to calculate the average mass of chlorine when you have 2 different common isotopes. Okay, so the abundance of this isotope is 75.77% abundance of this chlorine isotope, which is 34.96 AMU. And then this isotope, which is 36.95 AMU, which is 24.23% abundance. This 75 plus 24, that is going to add up to 100. Okay, or at least it should. All right. This is telling me that this particular isotope, if I were to round this number, this isotope is isotope 35, or I'm sorry, chlorine 35, whereas this isotope, which I round up, would be chlorine 37. When I do my calculations, I'm going to calculate the average atomic mass. Same thing, I'm going to take this percentage, divide it by 100, or move the decimal 2 places, 1, 2. Take that number times the AMU, which is 34.96, and then I'm going to add that to the same thing of the other one. So if there were more than 2 isotopes, you would have more information. All you're going to do is the same thing, change that percentage into a decimal, and then times it by the AMU. For each one, then you're going to add them up. So once I calculate this, it adds up to that. Okay, that is the average atomic mass for chlorine, which the way that you would know if you're correct, you would just check the periodic table. Okay, as long as this is close to what it is on your periodic table, you are correct. And again, you need to make sure that you're rounding to the right number. So since I have 4 significant figures, I have 4 significant figures here. I should have 4 significant figures for your answer. And then again, your units are the same. All right. Last one is we're going to do the practice. Okay, so for the practice, you are going to go through and fill out this chart. Okay, then in Canvas, I will post the answer key so that you can check your work. Okay, I will post the answer key later on. Actually, not right away. You are going to turn in this an assignment in order to get credit and for your grade as well. Okay, if you have any questions specifically on the practice, make sure that you reach out.